Okay, so in this video we're going to talk about integrals. What are they? Well, basically, integration is the opposite operation of differentiation, so it's the opposite of derivatives. But what does it mean in the context of a function? What does it tell you about a function? So, once again, let's use the example of um, the function x squared. And it looks a little bit like that. Okay, so what is an integral? An integral is a function that allows you to calculate all of the possible areas below the curve of, in this case, x squared. What do I mean by that? So, for example, let's say that this is 5. Okay, so if I want to know the value of the area of this uh, surface below the curve and between the horizontal axis, I would use integration in order to know that. I know it's a little bit counterintuitive to think that integrals are opposite to derivatives because it doesn't make so much sense, but trust me, they are inverse operations, and that's what we are going to be talking about in this video and in the following ones. Okay, so how do we integrate? If we are already stating that integrals are opposite to derivatives, it makes sense that you integrate by doing the opposite things from derivatives. So, okay, let's talk about the first rule. Okay, we are going to come back to this example and finding this area in a moment. But let's say that we have this function, again, x to the power n. What we are going to do in order to integrate, and let me present you with the denotation. Look, we have two important things that are key to the notation of integrals. This symbol that it's just like an elongated s, and this differential dx. It's always uh, necessary to write them. Maybe you will not realize why it's so important, and especially if you're an applications and interpretation student, you will not need to go deeper into why this is the notation, but trust me, it is super useful and it's super important, and you should write them properly. Okay, so remember, the original function comes between this s and this differential, and we integrate it by doing the opposite of differentiation. So if in differentiation we subtracted 1 to the exponent, here we are going to add 1 to the exponent. And remember that in differentiation we move this to multiply, so instead of multiplying we are going to divide by that new exponent, and that's how we integrate each term. uh, but let's discuss about something. Okay, here we have to include plus c, which is like the indication that we know that there's a constant, or there might be a constant that we cannot determine for sure what number it is. What do I mean? Sorry. If, for example, let's go back to the example, x squared plus 5. And if I differentiate, it will be 2x, and that's it, because the constant disappear. So let's imagine that I want to go back to the original function. If in this way I do derivatives, I do differentiation, Then I have to do the opposite to turn back, which is integration. So let's do that. No, let's add 1 to the exponent. The exponent originally was the exponent of this is 1. We add 1, and we divide by 2. That will give you, these cancel each other, that will give you x squared. But we have no way to know that there was a 5 if we didn't have the original function. And the same happens to any constant. We don't know if there was a 5, or if it was a 0, or if it was a negative number, or if it was pi. We can't not we can't know. So that's why when we integrate, we write the constant at the end, because that's a way to show that we are aware that there may be a number that we cannot fully determine. Okay, so don't forget about that. So let's go back to our original example. If this is the function, the original function, the integral, and let's here write it with the proper notation, the integral of x squared, don't forget the differential, should be like this. We add 1 to the exponent and we divide by that new exponent. Okay, so it will be x to the power 3 over 3. Now, if I want to calculate the value of this area, I just need to replace the x for the 5 in this case. Okay, so let's do it. It will be 5 to the power 3 over 3. And 5 to the power 3 is 125. And 125 over 3 is not divisible by 3. So let's leave it like that. Okay, this is the value. We can make an approximation. Let's say that we do this, and it's approximately 41.6 repeating. It's actually 41.6 repeating. That's the value of the area below x squared from the 0, from the origin of the coordinate plane to 5. Okay, so a few considerations. Okay, what happens when we have something like that? Let me make it longer. Okay, all of this area is positive, and all of this area is negative. Okay, because it's in the negative part of the y-axis. But if we use the integral to calculate the area until here, let's put a just because, the integral will be able to calculate it even considering that this is positive and this is negative. Okay, what happens if I want to calculate the area until here, minus a? Okay, so once again, if I use the integral and I replace by this value, I will get this area from the origin to here. Okay, and what happens if I want to calculate the value of the area between two given points, let's say A and B? Okay, well, that is called a definite integral. We're going to discuss about that in another video, but it's a super easy concept because you just have to find the derivative from here to B and subtract, sorry, the integral. We're talking about integrals, I'm sorry. Calculate the integral, the value of the area until B, and then subtract the value of the area until A. Then we will get all of this. Okay, that's it. So let's use this video to do a couple of exercises of very simple integrals, indefinite integrals, which is the proper term. We're just calculating the function that will give you all of the possible values of the areas. So let's integrate 3x power 5 minus 2x to the power negative 1 plus 5x, 5 square root of x, okay, minus 2 over x squared. And don't forget the differential at the end. Okay, so in a similar manner than with derivatives, in order to apply the rule for integration, we need to get rid of things like this and things like this by rewriting, okay? So, since we are not integrating yet, I am not getting rid of the integration symbol and the differential yet. I'm just going to rewrite the function so that I only have exponents and I don't have roots. Remember, this is x to the power 1/2, and I don't have variables in the denominator. And remember, in order to do that, we move it up with a negative exponent. Okay, so now let's integrate. So now, since we are integrating, we can get rid of these and of this, ds and the differential. Okay, so remember, 3x 5, but we add 1 and we divide everything by that number. Minus 2x minus 1 plus 1 over minus 1 plus 1. Okay, I just realized that the example that I gave is a case that is not possible, but let's move with it and then you will realize why this term is not possible to integrate. Okay, so let's continue. Try to think what happens in this term and maybe you will be able to realize why it's not possible. That's the only exception. Okay, but let's continue. 5x 1/2 plus 1 over 1/2 plus 1, and negative 2x minus 2 plus 1 over minus 2 plus 1. Okay, I am no longer in need to write the differential on that because I already integrated. Okay, let's simplify. Okay, that's 3x over 6, sorry, x to the power 6 over 6. But we can simplify this. 3/6 is just 1/2, so let me write it as 1/2. 1/2 x to the power 6 minus 2x, negative 1 over 1. Bueno, the negative 1 over 1, sorry, negative 1 plus 1, I'm sorry, I'm so tired. Power 0, and negative 1 plus 1 is 0. This is why it's not possible, because it's not possible to divide by 0. So you should be able to take into account that the only exception for this rule is when n is 0. So n should be 0, should not be 0 in order for this to work. Okay, but then what are we going to do with this example that I just created on the go? Okay, let's fix it. Let's make it a possible example and let's change it. The problem was, sorry, I need to make an exception here. I'm also, the exception is when the n is not negative 1. So n cannot be negative 1. That's when this doesn't work. okay? Because then you will be divided by 0, which is not possible. Okay, let's change it. Let's make it 3. Okay. Okay, negative 3, negative 3. Let's change this also. Negative 3, negative 3, and this will change. Okay, 2x to the power negative 2, because negative 3 plus 1 is negative 2, and this is negative 2. Oh, but negative by negative, negative divided by negative is a positive, so let's already get rid of that. Plus 5x, 1 half plus 1 is 3 halves over 3 halves, minus 2x minus 1, the exponent, and minus 1, the exponent. Oh, but negative divided by a negative is positive. So I will write it as a positive already, getting rid of this negative. Notice that I didn't do it here before because this negative is not for the whole thing. But since after simplifying the negative was for the whole thing, now I'm able to get rid of that with the other negative. Okay, once again, we don't like fractional exponents nor negative exponents in the answer. So let's get rid of them. I hope you already know how this works. So I didn't realize that this can be simplified. So I'm gonna get rid of this. This is just 1. Plus. Okay. This is 5 square root of x to the power 3. When we have something like this, when we have something divided by a fraction, we can just move this denominator to multiply. So I'm going to do that right now. That will be 10. Plus, okay, 2 over x, because this dropped down with a positive exponent. And that's it. That's our integral. Okay? So, in a future video, we are going to talk about the definite integrals.